The webinar is about three things: viewing, tools, snapshots, and reports. So let's just go into a frame. It's a reasonable size frame, and have a look at this new fangled toolbar, because that's what it's all about. Where's everything gone? How do I do everything? So first of all, viewing tools. We now have this cube for viewing, and you can click on the top, you can click on a corner, you can click on the back, you can click on the home. The home takes you right back out into ortho view. So that's very useful. You have the zooming and panning, and you will notice it's a lot faster than it was. I'm using just the roller of my mouse, so the roller allows me to zoom in and out. Clicking with the middle mouse allows you to pan as well. Rotation is with the shift held down, and you just then rotate up and down. Naturally, you've got these tools as well. So that's the easy bit. We've done away with one or two features from the toolbar, and we've made others more prevalent. We've reorganized into different groups. So I'm going to skip past this area first, because it comes into really the second part of our presentation. And naturally you can display your member sizes, and naturally you can display your beta angles and your length of members. You can also display your member numbers, and if you watch the drop list, you can display references. So beam 50, column 17. So that is the references that we had in the 2017. Likewise, node numbers X, Y, and Z. They're all pretty straightforward, pretty obvious. The next areas is your supports, and you can display your supports, but it also has a drop list where we can display the other supports if we had spring settlements or springs or settlements. I'll just turn those off. And then this is our end connectivity, our pins. In fact, I don't appear to have any pins in this frame. At the minute, it's all a fully rigid frame for whatever weird reasons we want to do. So it's just an example frame. We're not worried about the analysis of the design of this per se. And you'll now notice that we're displaying everything in multicolors. And this is where the 3D comes in. The 3D is also telling us whether we want to draw by section. So back to wireframe. And naturally we can come back from thick lines to wire, so it's down to very fine wireframe. So in here you also control the color by section and whether you want a key diagram for section sizes. Likewise, if I leave that there, I can turn on the actual physical sections themselves. And you'll notice, as we showed the last time, the zooming is a lot more accurate and fast. The graphics are superb. We're now using the latest DirectX to get all this working, and even in 3D there's no such thing really as a time lag when moving objects about the screen. That's easy, very, very straightforward. So we then have the other 3D objects, and that is, for example, pad foundations. If I design my pads, it would show the physical sizes. Otherwise, it just shows an arbitrary, I believe, a meter by 500 or 300 deep as the pads. Drawing short is very useful for seeing what is a continuous, what we used to call super member, physical member. As you can see down here, we have your physical members, and then you have component members in here, obviously, for that. Now, that's also very, very useful when you're out of 3D, because you can also still draw short and see these component and physical members where you want them. So as you can see, this big primary beam is one physical member. And then when we are in 3D, this last one is really where we draw the end plates onto the members if you want to do a CAD style drawing. But not to worry. I'm going to go back to Wireframe. I'm also going to go back here to turn off color by section. So let's just zoom out, zoom in, and now look at the frame loads. The frame loads are very, very useful, as you can imagine. And the dialogue for it now is a floating dialogue. So first thing we need to understand is that when we don't want to see it, we just minimize it and down it goes, and you'll see that you got your second dialogue there, and up it pops again. So you can play around with that. Everything is as you had previously. Naturally, you can also on a dual screen move it over to a second screen. No point in me doing that because you wouldn't see it. Everything else is really as before, but just a wee bit better set out. So a bit clearer. You want thick lines, you want arrowheads, and no thick lines. So you've got now little arrowheads coming down and the different intensities, as you can see over here, of different areas and aspects. You also control your finite element loads and what global axes of load. So your X, Y, Z, your normal to member loading, as in the wind loading, your normal to the binary axis, and also the good old-fashioned density, row for density, if you're just wondering. So that's your dialogue, and I'm just going to close that. Now, if we had gravity area loading, which we do, I can then display that, and I can color by intensity. I can display my key diagram. So we're in to PowerPad Plus, we're into MasterFrame Pro now. So both these do the gravity area loading, and you have direct access to these options on your dialog. So you can ask for values on your line loads. You can ask for values and you just turn off those for you. Very, very straightforward. You can also, and I'll just come back to that in a minute. Right, we'll turn off the gravity. So wind loading, that's your wind panels. We can choose a wind direction and we will see the wind loading. And naturally we can choose if we want to see the values for the coefficients of pressure. So we're now using either a building designer suite or the wind analysis add-on, which is in PowerPad Plus as well. So those are your coefficients, and these are the actual physical values. And if I just rotate that around, you'll see that we're getting 0.5 here for wherever my location of building is in the world. So if I go back to CP, you'll see you get 0.7s and 0.8s and 0.9s, and then 1.1s on the leading edges. But when you times that by the external wind pressure, it goes down. And then you have, as before, your zones. So all very, very easy to work. Now, one thing you have to remember about the new toolbar is that it's dynamic. And that means if I take this frame and I reduce the size of the frame, because you're using a smaller screen. I'm working in 1600 by 900, but if you're on 1440 or less, then it will compress the options down. So you'll see your 3D is still here, your wind is still here, but it's all compressed for you. So depending on the size of the structure, or sorry, size of your screen, that varies. The other nice thing is depending on what you've applied. So if I came along and wind loading and went to turn off the wind loading, use master key wind and close that down, it will then, when it needs to, remove this out of the list and widen the other bits to make everything a lot easier to understand. But I'm just going to come back in and apply wind loading again, put it on again. Yeah, we'll have that. and close. So there we go, our wind loading back on again. So the next thing I want to look at in the viewing is, let's do away with wind loading. Say for example we were going to look at the 3D structure and we were going to put our section sizes on, and we were going to look at just the first floor. So frame views, let's go to planet level 1. So there we go, planet level 1, and we'll have a bit of color. So we're having the different colors, we're having our section sizes listed here and everything. So that's beautiful. This allows us to set those values up. However, you come back in a day's time, an hour's time, 5 minutes time, and want to come back to this view. It's okay, you can go and you can say, show me planet level 1. But you then have to come along and turn on section sizes. You then have to turn on 3D. You'd have to turn on the key and the color by section. And that is where things become a little bit laborious. So what we created is something called snapshots. So right mouse click and you'd have add snapshot. You also have it just straight up here, add a snapshot. Let's give it a name first. First floor steel, and say save. We could quite easily stick this into a 3D orientation. We seem to be, there we go, and I think that's the one. Yeah, that's the one I want, front and right. So that's our normal view. Turn off the 3D, turn off the section sizes. Let's put the gravity on. Let's have our line loads, and let's not have our section size key, but let's have our key for all of this, and we can then create another snapshot called first area, and say save that. So I've been there. If I now want to go and say I want to go to snapshot, I want to go to first floor steel, or I want to go to first floor area loading. So this is where the snapshots are beautiful, because they allow you to set up a configuration of options along the top here and filter and go straight to those. Now what you can also do is create snapshots for the general views, and that's quite useful. What I also do, if I just take all of this off, go back out to full frame, take all the line loading off, take the gravity off, and go to 3D. What I frequently do is I create two 3D view snapshots. I'm going to call this 3D steel, and then I'm going to create another one that is just the wireframe. And there's a reason behind that. So 3D wire, and save. So I now have quite a few different snapshots that I can go to. So go to snapshot, and you'll see all the snapshots are here, and you can say I want to go to 3D steel, and it takes me into a 3D view with the steel shown with all the different colors, and that's great. So looking at these viewing filters again, we have these ones, and all they do is put the orientation and the members, whereas the snapshot says whether or not section sizes are on, whether or not frame loads are on, whether or not beta angles are turned on. And that's the difference. They're a lot more customizable. So now let's look at some more filters. So just turning off that, if you look at your view filters, we can, if you remember, in the old MasterFrame we had vertical, horizontal and incline members. They're still here, but they've been categorized into the view filters because let's face it, that's what they are. They are a view filter. So I could say I want to see vertical. So I'm only seeing vertical members or only horizontal, and I can do so. I can say show me only members that are 4, 5, 7, 1, 5, 2, and remember you always have to click the parent as well, and do so. You can say member design groups, and if I've got a design group called beams or design group called rafters, it would allow me to see those, and I have the design groups created but no members in them. If we had FE surfaces, we could actually hide and show different surfaces. So you could hide your first floor slab while viewing all the walls underneath that, and we'll have a wee look at that in a minute. So this view filter is also very, very useful because it has all of these additional features inside it that were stuck all over the page previously and were crowding the issue. Now, supports we've considered, 3D we considered, gravity we've considered. What we haven't considered is obviously line thickness is quite easy to work with, and saturation, that's just a modification to the color of the members, because we now have a fixed set of standard colors that we use, and we'll just go for a standard saturation. This makes more sense. In fact, if I have 3D on, you'll see this saturation allows me to show it a lot brighter or a lot darker. So it allows you to configure how you want to. So font size, pretty straightforward, and your wireframe dot size for your dots. Now, if you remember, we used to be able to come along, I'm going to turn off the color again. We used to be able to come along and display your node points. Obviously that's still there, but we had all these other settings, the ones that don't belong to view filters and things like that. They're still here and they're in here. So under general you can say whether you want to use custom printers. Under output you can say whether or not you want to use grid references. Under dots, you remember the old-fashioned draw bolt dots at ends that don't have two members coming into them, and draw dots on members that have a straight either side, so you would know where they are. So you still have all of these tools and facilities inside the system. Now, I'm going to exit from this a second, and I will save all those snapshots, by the way. I want to look at a structure with FE slabs on it, because I was talking about these filtering tools with regard to FE. So here we have 2 stories with 2 slabs, and I can come along and I can say surface filters, and I can say hide the first floor. And now I've got rid of the first floor, hide the ground floor, and I'm going to go for multiple select. So now when I look at this and plan, I will see only my wall loading and also my walls for FE surfaces, and that's also very, very, very useful tool for setting out. So the FE components are very, very useful. You also have these component filters, so you can actually hide the external boundaries so it doesn't draw everything with the shade. So you just have the wireframe if that's so what you want. You can hide your openings, you can do all those sorts of things, show your attached beams, which we don't have any in this. So again, very, very useful tools. So what I'm going to do is I'm going to now introduce you to reports. So I'm going to go into a very simple frame. It is in fact one of the tutorial frames that we provide documentation for. And it is a very simple 3D frame with one or two sections, not the right sizes obviously because we've been playing around and whatever. But if we look at our results, graphical results, bending moments, yep, they're there. And if we look at them envelope, we will see all our envelope. So take off the 3D, take off the color by section. So there we have an envelope at 1 to 50 scale. I'm going to reduce that to 1 on 100. And intervals doesn't really matter, but 250 mil just gives you more hatches. And you then have your deflected shapes and 1 to 50, and again deflected shape is 1 to 50, and we can show values on those so we can see our values. And obviously we want to see not the ultimate but the service cases. So that's my frame. If we look even closer, we will see that we've got our steel design. So we've got our steel design of all the members, and this frame is all done rigidly, and some of the members do fail, and that's of interest to me. I want to just make that fail as well. And obviously it now changes the section because it was the same elsewhere, and make that one now work and that one now fails. So we got a little mixture of passes and fails in here, and your struts and ties. So all your design checks all set up. So save those, yes, why not? Reanalyze, absolutely. Plain frame. So I've done my analysis, I've done my steel design, I've even done a couple of connections, steel connection design. So I've done a couple of connections in here as well. Whether they pass or fail is immaterial. I've done a couple of connections. I think there's another one there, and there's another one down there for pad foundations. I'm going to say no to that. And I've even done my concrete bases and sized all those up. In this case, a wee bit of a failure there, but those are all working at the relevant sizes. So why is this one failing? Let's have a wee look. What's wrong with it? It's the moments at the interface and the moments at the interface. So possibly 10s aren't quite good enough, 16s, and we're now happy with that size of pad. So we've done our design. We've done all our design, and save. And it now comes time to print all that out. And first of all, you want to print it out into one output document. So you would come along and you'd go right mouse click print graphics, and you'd show then the bending moment diagrams and everything and do all that. But we have a better way of doing it, and it's this thing called the report generator. So let's go into the report generator. So at the minute it is blank. So I'm just going to close that down without saving anything. Let's first of all have a look at snapshots. Snapshot 1, I'm going to cancel that. I'm going to say snapshot 1 is going to be front view steel by section with key diagram. And I'm going to ignore the fact that's a wrong section size, it's only academic. So I'm now going to add a snapshot called front steel and save that. I'm also going to create the basic ones, so I now have all of the standard. So I actually have a front view which has not got the same settings. If I go to front view, it would actually just turn off all that. I'm going to turn off all that and turn off the 3D, and I'm actually going to now edit snapshot, and I'm going to make this one front view just on its own and say update. So I've created two nice snapshots there. I'm also going to do my loading, and I'm just going to zoom out, and okay, all this loading in this case has all been applied onto the members. So I'm going to create a snapshot for loading, but I actually don't need to because I can just ask for that at report time. So let's go through and create this report. I think I've got enough snapshots. So first thing I want is a snapshot. So I'm going to take this and add it. And then I want the frame load diagram. I'm going to add that. And then I want the data file and add that. Maybe take that one and move that one. Oh, I've just duplicated that one. Going to remove that one, going to take this one and move it down. So I've got these three items. I'm going to now double click, and I'm going to say that I want it to be front steel. So I'm going to add, so the snapshot is going to print, it's going to be called front steel. The data, print data, I'm going to say list per group, and I don't want any notional horizontal loads. I don't want IX and IY. I don't need end releases and member orientations. Actually, I will take the notional at each level and just say apply. So that now knows what to print. I'm now going to come into my frame load diagram, and it's going to say, well, what do you want? And I am going to choose the dead plus live ultimate, and I'm going to draw the scale. And I forgot to check my scale. I'm going to draw distributed loads and point loads, and I think 1 to 10 scale and 1 to 10 scale, and I'm going to put values on, and I'm going to draw only y-axis loads, no FE, no density, just y-axis loads, and apply. So that's going to give me that. I now would look to do some diagrams, so graphical, and you can actually just drag it across and add it. And what I want this time is a bending moment at 1 to 50 at 250 intervals, and it's going to be the ultimate, and we're going to show values on the major axis only. It's going to give me the values and apply, and I'm going to add another graphical, and this time I want service cases, and you don't need to select the snapshot you're taking it from, but in some cases it's quite useful to say the snapshot, otherwise it just takes it from the full frame. In this case it's front view, so I'm going to add that. It saves confusion if you do apply it and say apply, so it's going to be front view, it's going to be deflection with geometry, and it's going to be show values of major only and apply. So if I go back to that one, I would probably select again that snapshot and apply. So I've done my analysis, I've done my main report. What I haven't given us is member forces on member stresses don't necessarily need those. You might want to give some nodal deflections out for particular loading case, but I'm not going to. So now what I'm going to do is I'm going to put in my support reactions. That sounds like a good one. And for support reactions, I'm going to select all supports, and I'm going to give it selected the maximum and minimum cases plus that one case, and apply. So I've now got my support reactions built in here. Then I'm going to go to Steel Design, and I'm going to apply Steel Design twice, and you'll see why in a minute. So Steel Design, just double click on it to edit it, and it's thinking about it because it's actually going through the steel and saying, right, let's add them all in, and let's select the critical for each group, and above that and critical portion only, and we don't need that, but I'm actually going to print in this case the summary, and I'm going to apply. And then for this one we're going to apply the same set of filtering tools, and we're going to go add them all in, and then I'm going to select only the most critical and don't need the graphics. So we're now going to only apply those. So that's my Steel Design. What's left? Concrete. I can say for my concrete, what do I want? Well, clearly I only want the pad foundations. So all briefs, and I don't need any of that, and I don't need that. I'm just going to say apply, and then I'm going to come down, and there should be one in here for connections if I'm looking. So take that across, and I'd probably put that below that one and move that down, get rid of that duplicate, go to joints, and I want all briefs, but I only want graphics and summary for only the selected loading cases, and apply. So now what I can do is I can very easily save that to become a template, and I can then pull it back in again. And I can use that template over and over again. The only thing is I would then have to walk through these and set which loading cases I want to print each time, because the program is brilliant, but it's not psychic, as you can imagine. It's not going to know which loading case to print, which scales to print at. So I'm going to set up my printer, and I'm going to go to PDF Creator, A4, Portrait, as a PDF, not to Word and not to physical printer, and I just say save. And I can say generate, or I can say close. If I say close, this is all stored with this file. I come back tomorrow, this is all still there. So generate, off it goes, and you'll see it's now walking through all. It's done 7, it's done that, it's on 8 pages, 9. I suppose the only thing that would be even nicer if it went check, 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 check as it was walking through them. You don't really have an idea of how many pages are to go, or how many options are to go. So it's now doing all the design checks on the different portions, and I'm going to put this in as document onto my template, onto my desktop. So there we go. There's my front elevation. There's my data file. There's my loads, and I think I guessed the wrong scale for those loads. There's my bending moment diagrams and my deflected shape diagram. And now my support reactions, my loading case 1 plus my maximums and my minimums. And now I have my summary of result design for my steel design. And then I have 1, 2, 3, 4, 5, 6, 7, 8, quite a few design checks that were critical output. And then, sorry, walking through that, we now have, I think I probably asked for all the design checks rather than the individual ones. We have my summary for my different connections of design checks and my base plates. And now I have my pad foundations. Bang, bang, bang. All done. So that is report generation. So I can come along and say now I want to save this as a steel 2D frame. So that lets me know that I shouldn't really use it for 3D frames, and it will appear here next time I come in. And I just say close, save my changes. So everything is so smart. Okay, next question Kieran's asking, in 2017 I could never find the equivalent to the 3D Model Manager wind loading bracing panel. Okay, for wind loading bracing panels, well, bracing panels really doesn't really matter whether they're for wind or gravity in some respects. But if I go into loads and I go into floor panels, there's where you can define in floor panels your bracing members. If I go into wind panels, I can define those. So if I was doing this as a wind panel frame, very simply they're already set up as bracing members. So it is all there. Yeah, again, asking about bracing members, it is putting them into a bracing member group so they do not get wind loading areas. That is correct. So because these are in a wind bracing, if I was to go and put a wind, this is a wind panel, and say it was horizontally spanning, the wind would span from that member to that member and from this member to this, and not try and put the loading onto the bracing members. That is what we're doing here. We're saying bracing members, or you could argue members that never carry my area loading. Same thing. How does the report generator work with FE output? Can the saved reports still function well within them? Well, let's have a wee look here at report generation. Again, finite element diagrams. I apologize. Don't know about finite element section, but finite element diagram is separate. So if I go in here, I can say what item I want. So FX, FY, MRX, or your AS, top or bottom. And of course, this is where the snapshots would be really, really important, because you'll be creating a snapshot for that surface view, so that you can then output that. So yes, you can do snapshots for finite element output. Can you do finite element? I think finite element sections are the ones where you take slices, yes, slices through the structure. So again, where you do the bending moment diagram through the structure, you're able then to look at those in the snapshots. So yes, all the different output for FEA is covered in the snapshots, and just cancel that. So absolutely we could do that. And the other one is actually set center of view using shift and left. And that's one that people never really think about. When I'm rotating here, it's rotating this about something. It's rotating about what it thinks the center of the frame is. It's not where my mouse clicks. Certainly zooming is from where my mouse is, but not the rotation. So it's taking about an arbitrary point. So what did it say? I've just forgotten because I don't use it that often myself. Mouse control, ortho set is shift and left click. So if I went shift left, that's now the center of my screen, and when I rotate things, that is roughly the point about which everything is going to rotate, which can be useful. So if I go back out and start to rotate, it's now set it back to the center of the frame, vertical and horizontal heights, of course. But I could set it shift left to be there, and there's now my center, or there, and it doesn't matter where I am. So I just did that twice by mistake. So there we go. So you're still panning, but I'm rotating. So yeah, it's very, very useful, that. Is there a limit to how big the report is? I don't know. I honestly don't know that answer. Possibly you could create 2 or 3 different sub-reports. What you can do in the reports, which is quite clever, is you can subgroup things so you can actually turn them on and off. So if you want to add what we call a container, then you can add things, and I believe you can put them into the container. Yep, so there you go. So you can have your 2 diagrams, and you could even then name these containers. So if you don't want that part of your report printed, you can turn off those 2 functions. So if I create another container and put that back here, and then do normal member diagrams and move that into that, so I could choose, and I could rename these by right mouse clicking and saying rename. FEA output, and you could say, and then you could call this one just frame output, and you can turn these on and off so you only print out the bit you need. So you can subgrade your output for that. Joe's asking about super members. Super members used to exist. They no longer exist per se. What I'm going to do is I'm going to create a member. So I want to create another member of this member into 3D. Doesn't matter what size it is, I'm just going to go create and add a member. I'm going to take a member and I'm going to say hover, get an X and move along 2 meters, press enter, and then I'm going to say I want it to go out in that direction by 3 meters. Okay, and then press, well, I can actually come and say, right, let's come down, vertically down to there. So we now have this 3D component. So if we remember about our little shortening tool, this is automatically, when we put the extra member in, created as a super member. We don't call it a super member, it's a physical member. But that is what it is in the background. So having done that, let's zoom in this area. And it is very useful to work with the member short, so you know what's continuous and what and super and what is not, what's a physical member you want to call it. So having done that, there are 2 functions, merge members and split members. Let's go and split these 2 members, this member. I am going to quick split or split and just say, let me see, clear, split this member and say apply. In fact, it's saying I don't know what to do. So we're still highlighted. You want to actually explode this super member. So apply. You'll also notice that we have none of this undo rubbish anymore. So now you'll see, and if I go clear, we have two separate members, two separate physical members on the frame. So you want to take these two members and make them back into a super member. Well, it's nothing more than the merge members. So merge members, we can do it in two ways. We can go and say merge that member and say proceed. Or we can go and say merge anything between that point and it will now be automatically done. So that is now one super member. If I do an undo, they're back to two and clear. So back to the merge members. You can also auto merge members between columns and between grid lines, and you can also remove redundant analytical nodes. So if you had a node in here you didn't need, that would do the same thing. Okay, so that was a very interesting question there. Super members still exist, we just don't worry about them. Can you export to Word? Absolutely. If you've got the Office tools, you can send your snapshots and all out, because snapshots is just saying give me the snapshot. And obviously don't forget the report can go to either Word or printer. So let's have a quick look at the base plates for Keith before we go on here and just wind up. So save that. So connection design, standalone. And I'm going to come in and create a brand new file called CHS. Create new. And it's going to be a base plate. Oh, just say close to that, it's just the defaults. Sorry, getting carried away. Base plate. So first thing, let's set it to be a CHS. So expand my column, change the type to CHS, back here, change the size, then down to something more respectable like a 244 by 10. Reasonable thickness, but still there. Okay. There's two things here to think about. One is this got pitch circle diameter bolts? If I say yes, it's going to insist on a minimum of 3. And I'm going to say 6. So as soon as I say pitch circle diameter bolts, it gives me a circular base plate. But it only gives me a circular base plate. If I said 600, it would assume 600 square, 600 by whatever the default is, 400. I'm going to take that back off. And if I set the length to be 400, that is the trigger that sets it. If I make this for 340, it's going to make it rectangular. If I leave the breadth to 0, it will assume when we have a pitch circle diameter that the plate is circular. Now, the other question you had there, Keith, was to do with stiffeners. Okay, let's give it a thickness, 10 mil. We're not seeing very much. Where'd my stiffener go? Support height, 150. End height, 100. That's lovely. Stiffeners, none. So what I can do is, it says I've got all the stiffener types here, but in reality I only have 2. I have 1, which is every bolt, and I also have type 2, which is every other bolt row. So every bolt is stiffened on one side only. There are no other stiffener types for the circular hollow section. So if I was to go back just to 2 and I was to play around with the plate size and make it 400 by 500, it's going to again give me the 2 stiffeners. So the stiffeners in circular hollow sections are slightly different in that they are either every pitch or every other pitch. Naturally, if I go for every other pitch and I just so happen to go for an odd number of bolts, it says don't be silly, you can't do that, and it puts them in every one. Whereas if I go 6 or 8, it does them every other, as you would expect. So that is the little tweak you have in the base plate. So one is that you only have 2 stiffener types, every bolt or every other bolt, and the second is that to get it as a pitch circle diameter, leave the breadth to 0. Naturally, you can have a 0 plate. Is it pitch circle? No. So it needs to be PCD as well. PCD and length, which makes sense. Only needs a length, doesn't need a breadth because it is a pitch circle. Okay, ladies and gentlemen, that is it. That is me. I'd like to thank you all for coming along. Hopefully you've learnt something today.